Okay, so today we will complete an activity that will take place in two parts. These activities will lead us into one of the most useful skills in mathematics called factoring polynomials. So we're going to get started here, but I just want to let you know before we get started that I'm going to kind of be going back and forth between a graph on Desmos and this note sheet. So if I say something while we're looking at the graph on Desmos, chances are I have written that down in my handwritten notes that I posted to Google Classroom, so you can check that out and jot down any clarifying statements that I make onto your note sheet. So let's begin. Here's what we're going to do. We're going to use Desmos to graph the function f of x equals 2x squared plus 5x minus 3. And we're going to use the graph to determine the coordinates of the x-intercepts. We're going to record our answer as an ordered pair, or answers as ordered pairs in the space below. And we're also going to sketch the graph that we see on Desmos. So the first thing that I want you to notice about this function is that it's not linear like a lot of the functions that we've looked at this year, and you've also looked at in years past. And it's not exponential like the functions that we looked at in the previous unit. It's a polynomial function, and its highest degree is degree 2. So this is actually a quadratic function. Okay, so just keep that in mind. So this is a quadratic function. Now, what you're going to also notice is that this graph, the graph of this function, is not going to be a straight line like we're used to, like a linear function, and it's not going to be an exponential curve like the exponential functions that we've looked at before. This type of function has its own type of graph. You may have heard of what it's called before. We're going to talk about that in just a second. So let's go ahead and take a look at the graph of this function. And here it is right here. I've already gone ahead and done this on Desmos. And if you'd like to do this as well, you can pause the video and go to Desmos so you can kind of work along with me. So again, if we look here, this is the graph of the function f of x equals 2x squared plus 5x minus 3. Clearly, it's not linear, it's a curve. And in this case, the graph intersects the x-axis in two spots. So it intersects the x-axis, it looks like at exactly 1/2, 0, and at -3, 0. So what we're going to do is we're going to go back to our notes, and we're going to record that. So the x-intercepts are -3, 0, and 1/2, 0. Now, what we can also do too is we were asked to sketch a graph of the function. So we'll do that over on the left-hand side here. And I don't really care so much about that minimum value, like where the curve goes from decreasing to increasing in value. All I really care about in our sketch is that we have the x-intercepts for now. Later on, we'll worry about all that other stuff. So the graph intersects the x-axis at -3 and +1/2, and it looks something kind of like this. And again, that is not accurate at all, but it gives us a general idea of what the picture looks like. So the graphs of quadratic functions are called parabolas. And sometimes what you're going to see is that the graphs of quadratic functions are going to intersect the x-axis 2 times. Sometimes they'll intersect the x-axis once. Sometimes they won't intersect the x-axis at all. But the question that we're going to try to answer here is, well, how can we determine the values of those x-intercepts without having to graph the function? And the interesting thing is it's kind of a combination of a skill that you're already familiar with and one that we need to learn. So let's continue to explore here. So the next thing you're asked to do is solve the equation 2x minus 1 times the quantity x plus 3 equals 0. Well, this is something that we just studied last week. To solve this, we have to apply the zero product property that we learned last week. So here's our equation. And because 2x minus 3 is being multiplied times x plus 3, and the result is 0, either 2x minus 3 has to equal 0 or x plus 3 has to equal 0 to make this equation true. So we're going to set 2x minus 1 equal to 0, and then x plus 3 equal to 0, and then we're going to solve. So we're going to get x equals 1/2 or x equals -3. Now, the interesting thing about this is if we take a look above, the x coordinates of our x-intercepts that we found on the graph of the function f of x equals 2x squared plus 5x minus 3 are exactly the same as these solutions that we found down here. So what we want to do is kind of see if this is a coincidence or if there's a reason why this is happening. So let's take a look at another example that will hopefully tie all this together. So number 3 reads, determine the product given 2x minus 1 times x plus 3. So we're going to do that right now. Now again, this is another skill that we learned about recently. The distributive property, some people call it FOIL. All right, so we're going to distribute here using FOIL. 2 times x is 2x squared. 2x times 3 is 6x. -1 times x is -x. And then -1 times 3 is -3. So if we simplify that down, we get 2x squared plus 5x minus 3. So again, this is really interesting because, again, I'm going to grab my highlighter here. This expression right here is equivalent to the polynomial that's on the right-hand side of the function up above. These factors right here, when multiplied together, give us that expression. So it appears that there is some sort of relationship between the factors of a polynomial expression, in this case a quadratic trinomial, and the solutions to an equation that looks like this, where it's a polynomial that's in factored form, and where the graph of the quadratic function crosses the x-axis. And there is a relationship between these things. And what we're going to do here is we're going to figure out a way to take a quadratic trinomial that's in standard form, so 2x squared plus 5x minus 3, write that equation in factored form, and that's going to allow us to solve equations that are in a form that looks like this, okay, which in turn is also going to let us find the x-intercepts of the graphs of quadratic functions. So we're going to start to develop that idea as we go into video number 2 of this introductory activity. Thanks, and we'll see you in the next one.